The understanding that the atmosphere can trap heat as a greenhouse may can be traced back 2 centuries to the work of 2 French physicists, Joseph Fourier and Claude Pouillet. Fourier, the elder of the two, was born in Auxerre in central France. He was orphaned at the age of 9 and later received schooling from the church, where, until the French Revolution broke out, it looked as though he could spend his entire career. Instead, staying in Auxerre, he worked as a teacher for 4 years, until, siding with the revolutionists, he joined an administrative committee. Unfortunately for him, being rather moderate, he fell foul of his superiors and ended up spending time under house arrest, until the fall and execution of Robespierre. Later, his career took an upturn, and in 1795 he began to teach mathematics at the newly established Ecole Polytechnique in Paris. However, in 1798 he joined Napoleon on his expedition to Egypt, and on return in 1802 he found himself governor of a district of Grenoble in the foothills of the Alps. While here, in addition to his administrative duties, he spent time working on a mathematical treatment of heat transfer, a work which was finally published as a book in 1822 after he had moved back to Paris. The book is perhaps most famous for his introduction of the Fourier series, which on later modification became known as the Fourier transform. But it was also a precursor to his subsequent focus on processes affecting the temperature of the Earth. And it was in these later works where he commented that the atmosphere of the Earth may be better at absorbing heat released from the Earth than heat from incoming solar radiation. Claude Pouillet, a professor of physics at Paris, later provided mathematical grounds for Fourier's statement, by calculating that the atmosphere absorbs more than twice the amount of emitted terrestrial heat than of incoming solar heat. Eventually, however, Pouillet's career was also impacted by politics. After the 1851 coup d'etat, Pouillet refused to sign an oath of allegiance to Napoleon III and was forced into early retirement. Within a few years, however, Eunice Foote, an American amateur scientist, and John Tyndall, a professor at London's Royal Institution, had provided an explanation for the findings of Fourier and Pouillet. They had both observed that gases like carbon dioxide and water vapour are efficient at absorbing heat that is released from the Earth. Later, and before the end of the century, Svante Arrhenius had further extended these arguments by calculating that a doubling or trebling of the amount of carbon dioxide in the atmosphere could cause a global temperature increase of up to 9 degrees C. Thank you so much for listening to the very end, and I hope to see you again sometime soon.